Data leak prevention, redaction, PII detection, prompt injection, RAG filters, agent permission, audit logs. Now there is a lot of noises here, and honestly, I don't think this needs to be this complicated. So I wanted to talk about a few things that actually matter and briefly explain how we even got here. Let's start with how security worked before copilots. Back then, security was built around one simple assumption: data mostly stays where it lived. It lived in a database, a file share, an endpoint, or even in a Gmail. So companies actually bought in tools that sat at the edges. They did simple things. They would scan for text, match patterns, even block uploads, and maybe redact a few documents. And that actually worked because workflow back then was very predictable. Then AI showed up and data stopped staying put. It started moving through conversations. When you actually use a copilot, you're constantly taking in data from somewhere else, like a PDF, a Slack thread, a claims system, and injecting them directly into a model. Then the model transforms them and sends them somewhere else. That means the security problem is no longer where the data is stored. It is now what got pulled into the context. And what did the model do with it? So we invented a dozen buzzwords for this: prompt injection, RAG security, agent tool calling, guardrails. But if you zoom out, you can compress all of these things into three simple buckets. Most AI data leaks happen because the model got access to information it shouldn't have. Not because someone hacked a server, but because the model pulled in extra stuff into its context window. This is why people talk about chunking strategies, retrieval filters, redaction, PII detection. All of that brings the same goal: control what enters the model. Now, in early days, teams tried to solve this problem with policy prompts. They would write a massive system instructions: do not leak sensitive data. Sometimes it helped, but usually it failed. Why? Because policies are not controls. Large language models are non-deterministic. Sometimes the model ignores this policy. Sometimes it just forgets. And sometimes it is confidently wrong. So the first pillar of security isn't asking the model to be nice. It is deterministic control over the context. A regular chatbot just reads through and writes text. But modern copilots are not just chatbots. They are agents. They connect to tools like Slack, Google Drive, Jira, and internal APIs. The moment the model can take in an action like sending a message, share a document, create a ticket, security turns into an access control problem. Tools are basically privileged access. So you need the same fundamentals you use everywhere else. Least privilege, read-only versus write-only separations. Approvals for risky actions. Allow list for where the data can be sent. Because if you don't control the actions, the model becomes really fast, really convenient way to move data into wrong places. How do you know it's safe tomorrow? This is a question nobody wants to talk about. How do you verify the system is safe tomorrow? Because AI systems can drift. You can change the model version. You can edit the prompt. You can also add in new tools. Even if it was safe yesterday, a small change can break your security posture today. So you need proof. Not just we wrote a policy, not we think it's fine, but actual evidence. Logs of what entered the context, records of tools and actions, automated evals to test for security leakage, regression checks so the security doesn't silently degrade. So to recap, AI CPD feels heavy because of the vocabulary. But the system is actually really simple. It's just three things: context, what the model sees; actions, what the model actually can do; proof, to verify it stays safe over time. Everything else, DLP injection, defense, guardrails, is just a feature inside one of these buckets. And this is exactly how we build Meteor AI. We keep sensitive data out of the context. We prevent unsafe actions. And we produce the evidence teams actually need for compliance.